Hello everyone. So today I'm going to talk about Introduction to Linear Data Structures. In this video, I'm going to talk about what are linked lists. A linked list is a linear data structure that consists of a series of nodes connected by pointers or references. So it consists of nodes where each node contains data and a reference or link to the next node in the sequence. Each node stores the data and the address of the next node. Address of the first node, a special name called as head. The last node in the linked list can be identified because its next portion points to null and it is called as the tail. So there are three common types of linked list. The first one is single linked list. The second one is double linked list. And the third one is circular linked list. So now I'm going to talk about what is single linked list. A single linked list is a linear data structure where each node points to the next node in the sequence. It allows traversal in only one direction, from the head to the tail. Each node in a single linked list has two parts. The data is holds and a reference to the next node in the list. Here you can see the head node pointing to the next node, and this continues until we reach the tail node, which points to null. So what are the applications of linked list? The first one is dynamic memory allocation. They allow for efficient memory usage as nodes as created and freed as needed. The second one is implementation of stacks and queues. Single linked list can be used to implement stacks as last in first out and queues as first in first out data structures. So now I'm going to talk about what is double linked list. So a double linked list is a more flexible data structure where each node points to both next and the previous nodes. This allows us to traverse the list in both directions. Each node in the double linked list contains three parts: the data, a reference to the next node, and a reference to the previous node. As you can see, each node is connected to its predecessor and successor, forming two-way chain. So these are the applications of double linked list. The first one is navigation system. So we can use double linked list in the browser history and music playlist, and in undo mechanism, in text editors and other applications where undo or redo operations are needed, and in complex data structures. So what is the difference between single linked list and double linked list? When we get the structure, single linked list has each node has a data part and a pointer to the next node. And in double linked list, each node has a data part, a pointer to the next node, and a pointer to the previous node. And when we get the memory usage, single linked list allocate less memory per node, and double linked list allocate more memory per node. And when we get the implementation, single linked list is simpler to implement, and double linked list is slightly more complex due to additional pointers. So now I'm going to talk about what is circular linked list. A circular linked list is a variation where the last node points back to the first node, forming a circle. In a circular linked list, there is no null at the end. Each node contains data and a reference to the next node, similar to a single linked list. And however, unlike a single linked list, the tail node points back to the head, creating a circular structure. So what are the applications of circular linked list? As we mentioned before, it is also has a dynamic memory allocation and implementation of queues. So there are common operations in linked list as search, insert, and delete. So in the insert, we can insert at the beginning and insert at the end, or insert at the specific position. And also in the delete, we can delete at beginning and or delete at the end, or delete at a specific node. So advantages and disadvantages of linked list are: the first one is advantages. It has dynamic memory allocation, efficient insertion and deletion, no fixed size limitations, and flexible data structure. And disadvantages are increased memory usage and slower random access, and potential for pointer errors and overhead for traversal. So thank you for listening. So this is the end of my presentation. Thank you for listening.